This is Motion Investigation Introduction. We're getting started on a new lab activity. This is a full investigation. You're going to be collecting some precision data today, as opposed to your last lab experience where you set up your own subjects to measure the motion data for, and you use your stopwatch. The issue with that is, you probably saw it when you plotted your data, the data points probably aren't in a perfectly straight line, so it's kind of hard to depend on them with a high amount of precision. So today we're going to use several precision instruments. And the first one, our subject, is going to be Lightning McQueen. He is the ultimate precision instrument. So he's going to be moving through a series of photogates. And the photogates is the other precision instrument. Instead of using a stopwatch that relies on a person to start and stop the watch, you probably noticed that with reaction time and judgment, it's difficult to get those watches started and stopped with a high amount of precision. So our step here is we're going to do a science thing. We're going to take our observations from our last investigation and try to improve upon our procedures to get some better data. You probably noticed from your last investigation that the faster objects had data slopes that were much steeper than the slower objects. So we're gonna jump off of that trend and take a look at two kinds of motion in this lab investigation. The first one is a constant velocity motion, and the second is an accelerating motion. So Lightning McQueen is going to move at a constant speed under his own power at first, and in the second segment he's going to be rolling down a hill uncontrolled with acceleration. And we're going to try to collect some more precision data with that. Now the way the photogate works, I'm going to tilt it a little bit so you can see, when it's blocked, see it light up? So it indicates when it's blocked and unblocked. And once I start the data collection here, as Lightning McQueen passes through the gate, you notice that the gate state says 1 and then 0. The 1 means it's blocked and 0 is unblocked. And it took precisely 0.378687 seconds to do that. So that's much better than probably what you collected from your stopwatch. Now I'm not going to have just one photogate set up because this picked up data for just one location. So you'll see 4 different photogates set up, one in front of the other, and lightning is going to pass through all 4. Now the starting gate is going to be the starting marker, the 0. So if I reset this data, your data is going to look something more like this. It's going to go through the first gate, then the second gate, then the third gate, then the fourth gate. Well, let me try that again. Collect. Let's get through the first one. There we go. The second one, the third gate, and the fourth gate. So you'll get 8 bits of data, 8 pieces of data, and you'll see blocked, unblocked, blocked, unblocked. We're going to ignore the zeros, ignore the unblocked. We don't really care how long it took for lightning to pass through each gate. We want to know when the front of that car got to each gate, because that marks his position, right? In the front is where he's going to be breaking those gates, so it's when the front gets to each of those markers is what's going to matter. We're going to collect that data. And it's only going to be 4 points of data, not 8. So if you count each of those ones, there are 4 ones, 1 for each time lightning passed through the gate. So if this were your set of data, it would have taken him 1.7 seconds to travel from the first to the second gate. Then another 1.68 seconds. So if I take the 3.38 minus 1.7, that would give us the time lapse, the time difference between those 2 points. Now, you're not actually going to be writing that particular piece of data down, but I just want to show you it's taking about 1.7 or 1.6 seconds in between each of these gates. The data you're going to collect is data point 1, 3, 5, and 7 when we actually run the data. So keep that in mind. It's whenever the gate state is blocked. That is going to be your data. Right? Now we're also going to separate these gates by 1 foot. You'll notice that there's going to be 2 pieces of track in between each gate, and each track is 6 inches long exactly. So each gate is going to be exactly 1 foot apart. So the distance traveled is going to be 1 foot, then 2 feet, then 3 feet, then 4 feet. And the time is going to be these different time segments. This is the starting mark, the 1 foot mark, 2 feet mark, 3 feet mark. So you're going to see that once the video pops up for the data trials. And I believe this is all you need for the introduction. I hope you enjoy this one. A little less setup and takedown on your part, so this lesson should go a lot quicker than the last one.